Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this second lecture of Module 10 on engineering geological facets of natural hazards and mitigations, landslide, earthquake and induced seismicity. In previous lectures we have discussed about concept of landslide, then effect of landslide on society, peoples and property of peoples. And now in this lecture we will discuss about landslide hazard zonation technique, causes and mitigation measures. In this lecture we are going to elaborate about landslide hazard zonation, causes and mitigation. Regarding this we are going to introduce about the concept of landslide approach, and then landslide hazard zonation, then categorization of different type of zones based on landslide hazard zonation, and causes, then mitigations. Friends, as you know, the landslide hazards zonation required because the landslide is causing detrimental effect on society, peoples, vehicles, road, dams and other engineering structures as well as society. The landslide problem is severe in many countries, particularly in mountainous region, and peoples of the world are fearing due to problem of such landslide disasters. Every year we are losing number of lives and property throughout the world. Particularly in India, we have severe landslide problem, particularly in hilly region like Himalaya, like Nilgiri and other mountains. Therefore, it is important to develop some tool for assessment of landslide susceptibility in different area, along road cut slopes, along valley side, along residential area, etc. The researchers have attempted this problem to develop some hazard zonations keeping different parameters, as the landslide is a natural hazard. Therefore, number of parameters are affecting this hazardous phenomena. Some of the parameters related to geoground condition, some of the parameters is external as in form of forces, some of the parameters due to surrounding, and some of parameters due to human activities also. The various researchers, engineers, scientists and engineering geologists have attempted the problem keeping different parameters in different way. However, this type of problems requires integrated approach considering different aspects which are going to influence the landslide hazards phenomena. Recently, we have developed landslide hazard zonation based on features present in geoground in view of rock mass characterization and strata assessment. One of the easiest way to carry out landslide hazard zonations, we have considered different parameters inherited in geoground and map the whole area in view of influencing factors. So therefore the landslide hazard zonation is an important tool for designers, engineers, engineering geologists to classify the geoground into different landslide hazards zone based on the degree of susceptibility of area to the landslide hazards. The landslide hazard zonation is principally based on the causative factors which are going to influence the stability aspect of slopes. Regarding the landslide hazard zonation, we are initially attempting the problem keeping the scale of study in mind, and based on scale of study the landslide hazards map or zonation is classified into three classes as mega scale zonation, macro scale zonation and micro scale zonation. At mega scale zonation is related to regional scale study, and this regional scale study is based on the scale of mapping 1:50,000 or even more to cover a large area step by step. In microzonation, where we are going to evaluate about the risk, therefore also known as risk zonation. This risk zonation attempts on scale 1:25,000 to 1:50,000 scale. However, the micro zonation is ranging in scale from 1:2,000 to 1:10,000. Nowadays, we have also selected some scale less than 1:2,000, even 1:500 or 200 for detailed analysis of the features going to influence the landslide activity. The factors which are going to influence for formulation of landslide zonation are important, as these factors are governing the phenomena of landslide. The factors important for such formulation is a lithology, structure. Structure is dealing with the relationship of the structural discontinuities with slope phase. Then slope morphometry, relative relief. The relative relief explains about the height of slope, and then land use and land cover, and then groundwater condition. If we are going to see about each parameter, then we can say that the lithology consisting of rock and land type made up of soil, debris and others. Overall, this lithology is representing in our discussion about the geoground. The geoground comprised of varieties of material, some intact, some in form of rock mass, some in form of weathered, some in form of fully converted form as in soil. Considering the lithology, we are going to see the overall distribution of lithology throughout a particular area. Suppose this is the area, then we are going to map this area in view of distribution of different lithology. For example, suppose sandstone, then here limestone, then here shale, then here dolomite, then here some igneous intrusions like basalt. In this way, when we are going to take the traverse, we can see the variation sandstone, shale, limestone. If here, then we can say the shale, then the dolostone or dolomite and basalt, etc. So in this way, we are going to distribute different lithology or level in field in form of map. Then about the structural or structure Structure is about all kinds of discontinuities including fold, fault, foliation, lineation, cystosity, bedding planes, cracks, fractures, etc. How the crack, fractures and others in form of structural discontinuity develop some relationship with slope, or what is the connection with the face of slope. Suppose this is the face of slope, and where suppose we are going to see about the distribution of the beddings, then what is the relation? We can define the relation with help of the angle of these beddings and with respect to, so dip of this beddings is toward the downward slope side, where this face is having a particular phi 1 angle, where this bedding with respect to face is showing theta 1 angle, almost same, theta 1 dash angle, theta 1 double dash, theta 1 triple dash, where the theta 1 dash, theta 1 double dash, triple dash almost same. In this way we are going to see about the role of structural discontinuity in triggering the landslide process or phenomena. Another important aspect is the slope morphometry. The slope morphometry is dealing with the features of slope in terms of features available in this slope, along with width, different cuts, about the depression caused by some previously developed slides, about the zonation related to loose material, solid materials and others, about the drainage system present or draining the slope, etc. Then we are going to see about the height of slope. The height of slope, this is the angle of slope. About the width of slope, we are going to measure in slope morphometry. Then particularly about the height of slope, we are going to define under the heading relative relief. This relative relief we can define by topographical view in terms of elevations with help of different contours and others, as well as physical measurement. Land use and land cover indicates about the parameter concerned to distribution of different landforms in the area of study, belonging to some river form, some weathered material, some aeolian form, some glaciers form, etc. And then the part of the area covered under the forest, part of area covered under the vegetation, part of area under the shrub distributions and others, and some of the area is a barren land. So in this way we are going to assess about the part of the area covered under forest, part of the area covered under grasses, part of the area covered under agricultural land, and part of area barren, part of area under residential zones. So such type of division is going to produce about the features of area in view of land use and land cover, because the forest, different type of plants, different type of grasses are going to influence about the landslide occurrences. Then important aspect is a groundwater condition, and groundwater condition is a very important. As we know that rocks as well soil or any type of material under saturation is going to lose their strength. If there is a reduction in strength, in such situations there is more possibilities for formation of failure plane, and the mass lying above the failure plane is going to slide downwards under the influence of gravity easily in comparison to the dry condition. Therefore, the location of the water table is very important from stability point of view. If we are going to see about landslide zonation approach, the one of the landslide zonation approach formulated by Gupta and Anbalagan in 1995 become popular for various type of use, as the system is a simple, partially semi-quantitative and easy in adaptation by different communities, particularly geological communities, as the system is incorporating the parameters which is close to the geological perspective, theoretical in nature, and can be easily measured without any complications within limited time span. So they have proposed maximum landslide hazards evaluation factor in short form LHEF rating for different contributory factors which are going to influence the landslide phenomena. As we have already discussed, in landslide zonations we are going to cover about lithology, structure, slope morphometry, relative relief, land use, land cover and groundwater. So they have arranged these parameters according to their importance, but going to provide some maximum possible landslide hazards evaluation factor for each factor. For lithology, as the lithology is going to influence the strength of slope or any mountainous region, therefore maximum emphasis we are going to give about the lithology, and the maximum LHEF rating for the lithology is 2. Friends, as you know, the rock strata is consisting of lithology rock as well as structural discontinuities. Under the structures we are going to see about the traverse of different structural discontinuity with a slope which are more contributory in comparison to other factors like land use, relative relief and groundwater. Therefore, this aspect we are going to provide 2 value for structure, and similarly morphometry about the width, about the slope, about the features present in slope is going to participate in landslide phenomena. Therefore, again we are going to put the value 2. So for lithology, structure and slope morphometry we are going to allot rating value as 2, 2, 2, and for relative relief as height of slope, because we have already incorporated width, slope angle, about the features present in slope under the slope morphometry. Then for relative relief, particularly for one factor height, we are going to give 1 rating value, and land use and land cover is also going to influence the landslide, because the forest, grassland, agriculture lands, barren lands, residential lands are going to influence the landslide phenomena. You have idea about the role of forest, role of grasslands and others in protection of the soil slopes or rock slopes, and number of vegetations also we have recorded in our past regarding the deforestation and others to protect the slope of mountainous region. Therefore, for land use and land cover, we are going to provide two numbers for rating value, and for groundwater condition, we are going to provide one value. So, total rating of a landslide, we are going to give maximum 10. In this way, we can calculate about a rating for different area affected by landslide hazards. The lithology may be vary from 0 to 2. This is the maximum value and minimum value is a 0. Then structure 0 to 2. Slope morphometry 0 to 2. 0 to 1 for relative height, 0 to 2 for land cover and land use, and then groundwater 0 to 1. In between these we have values, like here suppose 1.8, here suppose 1.2, here suppose 1.5, here 0.8, here 1.3, or here 0.5. So total you can see about the value, calculated value, and then you can put this value in different type of gradations. In view of calculated total evaluated hazards factor value, we are able to categorize the landslide hazards in 5 zones, starting from very low hazards up to very high hazards. If the value of the total evaluated hazards rating, as we have already discussed, in maximum value of 10, if this total hazards evaluated hazards rating value is less than 3.5, then we are going to categorize such type of area fall under very low hazards zone, VLH. And this VLH indicates about the status of area as safe for development schemes. Means the peoples can construct a road, construct bridge, construct building, construct other engineering structure safely. If the value of total evaluated hazards rating ranging between this 3.5 to 50, then we are going to categorize such area under low hazards zonation. And this low hazard zonation is also suitable for development schemes similar to the previous zone, VLH. So this low hazard zone is suitable for construction work, development work, expansion work, resettlement work, etc. Then third zone, the value of the total evaluated hazards rating ranging from 5.1 to 6.0, the area fall under moderate hazards zone, MH, where we are going to observe local vulnerability zone of instability. Some localized pockets of the area is under landslide zones. Such localized landslide zones require some proper treatment and mitigation measures for suitability. Then 6.1 to 7.5 is hazards, high hazards, HS, and unsafe for development scheme. This area is not recommended for any type of expansion program or construction program or development program. and when this value is more than 7.5, then the area similar to previous is unsafe for development works. The such results are presented in form of maps, and then map can be created by two types of work: laboratory and field-based work. Field-based data processed under laboratory condition, and then we are going to show all the factors in a selected area on map as a different layers, as we are utilizing in ArcGIS also. The geoground evaluation maps are prepared in first stage, imparting the nature of aspect-wise distribution of parameters, as we have already discussed, and the area evaluation or evaluated maps are superimposed, and the total evaluated hazards rating is evaluated for individual aspect. Then subsequently the landslide hazards maps are prepared based on aspect wise distribution of total evaluated hazards rating determined results. You can see the distribution of different hazard zones throughout India, the very high hazard zones, then high hazard zone, moderately high hazard zones, low and very low hazard zone. जो major part under very low hazard zone or very low hazard zones, and some Himalayan parts as well as some mountainous region is fall under moderate and very high hazard zones. As far as mitigation is a concern, we are having some simple mitigations measures like slope modifications with help of excavating the vulnerable slope and filling up of the material to protect the slope. In this way we are going to reduce the slope which are going to affect the landslide hazards. As per our discussion, we have already discussed, if a slope is saturated with water, then it is more prone to slide due to easy failure of slope along a potential failure plane requires some dewatering. Therefore, we are going to put some perforated pipes to drain out water on collector galley and then release this to make this zone unsaturated and reduce the landslide probability. Next, about the construction of retaining wall. In this way we are going to protect the road from the landslide. Here you can see the concrete walls we are going to put. Sometimes gabion structure which are wired net of steel wires filled by the boulders is also utilized to protect. Sometimes crib walls we are going to construct with help of wooden poles or concrete units in cells, which are also going to protect the landslide problem. Besides this, we are having different anchoring method by use of bolting perpendicular to the discontinuity plane, by using short crating to stabilize the weak strata which are prone to slide, and then utilization of geogrids to protect the slope safely, economically and timely. As far as causes is concerned, the major cause behind the landslide is a gravitational force, then about the water induced forces due to rainfall, heavy rainfall inducing, then supplemented by the seismic shocks, slope angle, and the about the slope morphology. Steeper slope, the greater the chances of failure due to enhanced effect of gravitational pull. Absence of surface drainage and seepage from internal sources promote the slope failure during and after heavy and prolonged rainfall. and if the rocks are sheared and shattered, they will naturally become saturated with water and reduced in shear strength, which consequently going to lose the strength and going to accelerate slide. The seismic shocks are the biggest triggering factors because they change the stress pattern in rocks, and the slope angle is a very important. The steeper slope is prone to slides, where the modified slope is going to show some minimum chances. The addition of weight on slope like mine waste dump and other dumps, construction of buildings, construction of dam, or any weight on slided outcrops or weak zone is going to accelerate landslide problem. The road building activities also contributing instability of hill slope due to development of fractures and others, which are going to change the geomechanical response of rock masses in comparison to original situation. Friends, this material I have prepared from paper written by Gupta P. and Anbalaganar in 1995 regarding landslide hazard zonation, mapping of Tehri Pratapnagar area, Garhwal, Himalaya, published in Journal of Rock Mechanics and Tunneling Technology, volume 1, number 1, and in page 41 to 58. Then partial supports from these books: Gangopadhyay written Engineering Geology book, and the Engineering Geology book written by Bell F.G., and the Koshabulu about the textbook of Engineering Geology in 2016. Friends, landslide hazard zonation is one of important tool for demarcating the landslide in view of their susceptibility to slide in terms of causative factors. The landslide hazards can be classified on the basis of scale as well as rating for different causative factors. The modifications in slope, dewatering of the slope, and implementation of support system, application of support systems, and geosynthetics are relevant to mitigate the landslide up to certain limit. And in case of heavy landslide, the construction of protecting wall, buttresses, crab walls, and gabions are found suitable for minimizing the slide problem. Dear friends, in this class we have elaborated about landslide zonation, mitigation, and causes behind the landslide. Thank you very much for your patience.